Good afternoon, everybody. Today, I will be going over how to properly set up, design, and operate the Siemens robot that is inside of the K2200 building at Seneca Polytechnic. So, to begin, what you want to do is you want to make sure that you are running the TIA portal version 15. All right, I find that this version functions the best. You're able to get this either just off of offline, right off of the TIA portal, or if you are a student at Seneca Polytechnic, you can just get it right off of My Apps. So after you have that running successfully and you open it, you will see this page. What you want to do is you want to start by creating a new project. You want to name this project anything that you want, anything recognizable, and then put it somewhere that you will remember. After that, next step will be you will be going to the devices and networks tags and add a new device. What you want to do is you want to add or create the virtual version of your real life components that you have available. So that is what we'll be doing. We'll be looking to create the main controller and then the input, output, and server module for this PLC. So we'll be going over to controllers. In this case, if you are working in the labs at Seneca, you'll be following this exact format. If you have your own, you'll have to double check which exactly ones you have and adjust these instructions accordingly. But for the moment, for the ones we have available, we'll be going over to the Symantec E200 CPU, submenu ET200SP, CU, CPU, and then to the second gold option under that is currently highlighted at version 2.5. When you add that, you'll see a representation of your PLC. Now, everything that's grayed out are additional modules that you can create and add, but we won't be needing to do that. So you can ignore the darker grayed out section that is here. Now, as you'll see, the rest of these are currently empty as compared to the ones we have to the left side. So what we'll need to do is we'll need to create the inputs. So you'll go over to the catalog on the right side of the page, and you'll click on DI. The ones that are in the labs are the DI 8x24 VDC HF, and you'll be putting in the version 1.2 on this. It'll start out at version 2.0. You will need to change that. All you'll need to do is, once you have changed the version, drag and drop it into slot 2. And then it will appear as so, and you'll be able to see exactly which module you have. After that, you'll be closing that submenu and opening up DQ, which is the output. I for input, Q for output. You'll be selecting the DQ 8x24 VDC. And same thing, it'll be version 1.2. Once you've changed the version, then drag and drop it into slot 3. After that, you'll be selecting server modules, and as there is only one, that will be version 1.1. And you will have a complete PLC created virtually after that. Now, in industry, you will not ever do this next step. You will only be doing this if you're operating within the labs at Seneca, where you will be going over to right-clicking on the main PLC head and then clicking properties. It will open up this submenu. From here, you're going to go over to failsafe, and you're going to be going to the F activation and clicking disable. And then you will see two crosses over two safeties. You will be deleting these from your main OB program blocks under the PLC listed that you initially selected. Under program blocks, underneath main. You will want to only keep main OB1. Now that we've fully selected the PLC, you have downloaded the correct TIA portal version, you have made the virtual representation of your physical PLC. What you need to do now is create your PLC tags. Now, these tags are representations of real life objects, such as the buttons that you see available next to the robot. Now, I've been mentioning inputs and outputs. Inputs are something like a light switch, like these buttons, where when you push, you are essentially inputting you are giving the button a command, and it will send a signal to something along the lines that something will be the output, which is that Q representation on line 4, which I have aptly named light. So when you click the button, it will send a signal as a 1 to the light, and when the light reads that 1, the light turns on. Now, in order to make that happen, what you will need to do is you will need to click OB1 on your left side panel here. And then from here, we can start the next step, which is designing your PLC. As you have the lighter versions of the tags. Now, this next demonstration is just to get an understanding of how these tags function inside of the program. So what you have is your open gate, closed gate, and your outputs, along with the alternative branches and the reconnecting branches. So after you have familiarized yourself with these buttons, when you put them onto your networks properly, when you see these gates, what this means is this is a normally opened gate. What this means is that when you push in this button, it will close the gate and it will complete the connection. Now, the normally closed push button, which is the black button here, is the opposite. Normally closed, meaning that there is already a connection, and when you push it, it breaks that connection. So this acts as a stop button, and the white button, the normally open, acts as a start button. So how this reads is when you click the start button, it will send a positive signal through this line, and it will confirm that this gate is closed, as this button is not pressed but already closed, and it will run along the line to your light, which is the output, and it will send a positive signal to the light above, to this red light on the left, and it will turn the light on, only while this button is pushed. Now, the next introduction that I have to you is the memory bits, which, as you see, there's I's, Q's, and M's. Memory bits are extra forms of memory, just like how your desktop has, where it will store a value within your program and retain it to this name. So if you use this name on a later date, it will be able to recall it and to whatever value that you have saved it as. So I'm using this as a way to keep the light open. So if this light is on, this will turn on, making a latch is the technical term to the main line, keeping the light on, so we only need to press the button once and we don't need to click it again. When we want to turn the light off, all we have to do is push the close button, it breaks the connection, and as that connection is now broken, the light turns off, and this gate turns open. And that's the basic functioning of the light. With that in mind, we can now move on to the next step, where we will be designing the commands to operate the robot. Now, we need to account for all the basic movements of this robot, which is up and down and left and right. So we'll be utilizing the set and resets. Now, that latching I used as a way to keep the light on. The alternative way to do that is using set, where it keeps the value of an output at 1 until it is reset, which turns it back to a 0. So the tags that I've used are additional memory bits that you will be adding into your original PLC list. So you will have these HMI, which is human machine interface, which is a screen that will be already set up for you, where when you push HMI down, it will set the moving down output command to 1, which will cause this robot arm to extend and move down. When it hits the lower limit, which is a sensor that is being applied onto the robot, that sensor acts as an input, like a button, and then sends that command to reset as a 1, turning that set to a 0, turning off moving down. So that way it doesn't just shove itself into the floor, which would not be the best ideal. So applying that logic, you repeat that sequence for every single command, moving down, moving up, moving left, and moving right. So anytime you would push these buttons, it goes in the direction intended and not any further past the set limit that you have pre-designed or that you can place yourself. Now, with these tags and these commands in mind, you have now created your operational robot so that you can move up, down, left, and right for the basic commands of how to control the robot. Thank you very much. Don't forget to like and subscribe.